Hello my dear friends, welcome to the all of you. Myself Dattu Patel, Assistant Professor from LJIT. Earlier lecture we are already discussed about the to finding the particular integral by case 3, that is binomial expansion. Today's session we are going to discuss about the shortcut method as a case for whenever our q of x in terms of product form means exponential into v or v of x means q of x equal to e raised to x into v, where v is a function of x. See, at that case what we have to do means here v of x, that is function of x, means suppose v of x has a sin x, cos 2x, sin 3x or x square, x cube, means in terms of sine or cosine as well as polynomials of x. See, at that case what we have to do, e raised to x will be comes out, that is the formula of yp equal to 1 upon f of d into r of x or q of x. Then e raised to x comes out, then it becomes e raised to x into 1 upon d, which is replaced as a d plus a. Then here values of a, that is here, then d plus a of v of x. Suppose here values of a, that is negative, then 1 upon f of d e raised to minus ax into v of x. For that what we have to do, e raised to minus ax will be comes out, here minus sign, e raised to minus ax, and d will be replaced as 1 upon f of d minus a v of x, or d will be replaced as a d minus a, here e raised to minus ax. Let's move on the one example. See, solve the d square plus 4d plus 4 of y equal to e raised to minus 2x sin 2x. See, whenever we finding the general solution, what we have to do, we require two solutions. One is complementary function, another one is particular integral. See, in general solution is nothing but the combination of complementary function and particular integral. See, let's see first finding the complementary function. Whenever we finding the complementary function, we require the auxiliary equation. Here auxiliary equation, which is d square plus 4d plus 4 equal to 0. Then according to the basic algebra formula, a square plus 2ab plus b square, then it becomes a plus b whole square. Then values of d equal to minus 2 minus 2. Here factors are real and repeated. Then here case 2 of for the complementary function, then complementary function yc becomes c1 plus c2x e raised to minus 2x. That is our equation number 1. Now move to the finding the particular integral. Then yp is equal to 1 upon f of d into q of x. Now substituting the values of f of d and q of x, then how we can identify which one is f of d and which one is q of x? Then whatever the differential equation which is given to you, here operator terms that is indicated by the f of d, that term will be indicated by the f of d, and is equal to something in function of x, that is indicated by the r of x as well as q of x, any variable you can consider. Then yp is equal to 1 upon d square plus 4d plus 4 into e raised to minus 2x into sin 2x. See, here in denominator portion d square plus 4d plus 4, then according to the basic algebra formula, it becomes 1 upon d plus 2 whole square e raised to minus 2x sin 2x. Here apply the case 4 to finding the particular integral. Then e raised to minus 2x comes out, replace d as a d minus 2, replace d as a d minus 2, then d minus 2 plus 2 whole square, here 2 will be cancelled out, then it becomes 1 upon d square sin 2x. See, here we can apply the 1 upon d, then integration, then 1 upon d square, then we can apply 2 times integration of that particular v of x, that is sine. Otherwise we have the apply d square is equal to minus a square, case 2. Here any method you can consider, other you can apply 2 times integration of v of x as well as replace d square as a minus a square. Let's move on. E raised to minus 2x, 1 upon d square sin 2x, then values of d square is equal to minus a square by case 2 for the shortcut method. Then values of a is equal to 2, then e raised to minus 2x minus 4 sin 2x, then it becomes minus e raised to minus 2x by 4 sin 2x, that is the values of yp of x. Now general solution y of x equal to combination of complementary function and particular integral. Substitute the values of CF and PI, that is C1 plus C2x e raised to minus 2x minus e raised to minus 2x by 4 sin 2x, where C1 and C2 are arbitrary constant. Let's move on the one more example for the better understanding. Solve the d square minus 2d minus 1 of y is equal to e raised to x cos x. See, sometimes our example may be asked as a y double dash minus 2y dash minus y equal to e raised to x into cos x. Maybe in terms of y dash, y double dash, this one is our higher order ordinary differential equation, 2 times derivative, then we can say that it is second order ordinary differential equation. Then first what we have to do, rewrite the equation, means d square y minus 2dy minus y equal to e raised to x into cos x. Here y will be common out, then d square minus 2d minus 1 of y is equal to e raised to x into cos x. Now our auxiliary equation is m square minus 2m minus 1 equal to 0. Now we cannot factorize directly, then with the help of Sridhar Acharya formula, minus b plus or minus root delta, which is b square minus 4ac upon 2a. Now which is minus b, that is minus 2 minus minus plus b square, that is 4 minus 4ac, that is minus, here divide by 2 into a, that is 1. Now here 2 plus or minus, then 4 minus minus plus, then again 4 divided by 2, then 2 plus or minus 8 root 8, that is 4 2s are, then 2 root 2 divided by 2, then 2 will be cancelled out, then 1 plus or minus root 2, means here our factors are 1 plus root 2 and 1 minus root 2, means apply case 1, factors are real and distinct, then yc of x equal to c1 e raised to 1 plus root 2 x plus c2 e raised to 1 minus root 2 x, where c1 and c2 are arbitrary constant. That is our equation number 1. See, here our factors in terms of 1 plus root 2 and 1 minus root 2, that is a real and distinct value. Then we can apply the case 1. Let's move to the finding the pi. We have the formula yp is equal to 1 upon f of d, then d square minus 2d minus 1 of into e raised to x cos x. And according to that, what we have to do, here e raised to x comes out, then replace d as a d plus 1 whole square minus twice d plus 1 minus 1 into cos x. Now simplify that term, then here d square plus 2d plus 1 minus 2d minus 2 minus 1, then here 1 1 will be cancelled out, here 2d will be cancelled out, then cos x, then our term becomes e raised to x 1 upon d square minus 2 cos x. Then according to the case 2, replace d square equal to minus a square, then minus 1 minus 2 into cos x, then e raised to x by minus 3 cos x, that is the values of yp of x. Now general solution is y of x equal to yc plus yp. We have the formula of yc, that is c1 e raised to 1 plus root 2 x plus c2 e raised to 1 minus root 2 x plus yp, which is e raised to x by 3 negative sign into cos x, means here sign will be negative. That is our general solution y of x, where c1 and c2 are arbitrary constant. See, whenever we finding the particular integral and case 4, then it is the combination of, first you should apply case 4, then after you can apply case 2 as well as case 3, because sometimes our function in terms of cos or sine function or sometimes our function which is in terms of x square, x or polynomial form. At that case we can apply the case 3. Means such kind of example we can apply case 4 or 2 or 3, any combination of case 4 to case 4 and case 2 as well as case 4 and case 3. That is depends on example. Let's move on the one more example. See, d square plus 2d plus 1 of y is equal to e raised to minus x by x square. Here, whenever we finding such kind of example, firstly find the auxiliary equation, that is m square plus 2m plus 1 equal to 0, then m plus 1 whole square equal to 0, then values of m equal to minus 1, then yc of x. Here apply case 2, factors are real and repeated, then c1 plus c2x e raised to minus x. Now we have the formula yp of x equal to 1 upon f of d into q of x. Just substituting this value 1 upon f of d, that is d square plus 2d plus 1 into e raised to minus x by x square. Now simplified that term. For that what we have to do, that is yp, then it becomes 1 upon d plus 1 whole square into e raised to minus x upon x square. Now here according to the case 4, e raised to minus x comes out and d which is replaced as a d minus 1, then d minus 1 plus 1 whole square into 1 upon x square. 1 will be cancelled out, then it becomes e raised to minus x upon d square. Here we can written as x raised to minus 2. See, you know that whenever our function which is 1 upon d, then we can apply single times integration of u of x dx. Then here 2 times, then we can apply 2 times integration, then 1 upon d kept as it is, integration of x raised to minus 2 dx. Now here e raised to minus x 1 upon d and 1 upon d into this one, that is apply integration, then x raised to minus 2 plus 1 upon minus 2 plus 1 integration of minus x square, then e raised to minus x kept as it is 1 upon d, it becomes minus 1 upon x, because x raised to minus 2 plus 1, that is minus 1, then it written as 1 upon x, and minus sign will be common, then again integration of 1 upon x dx, then it's become minus e raised to minus x log x to the base e. This one is our yp of x. Now general solution is y of x equal to yc plus yp. Now whenever we finding the general solution, that's substituting the values of yc. Here yc, that is m plus 1 whole square, that is factors are real and repeated, that is c1 plus c2x e raised to x, and this one is a negative sign, means here minus e raised to minus x log x to the base e, otherwise you can written as a ln x. This is our answer, what we have to find exactly. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.